Hi, this is Mrs. Kidman, and in this video, we are going to be discussing one-to-one functions. So what are one-to-one functions? Well, let's start by talking about what makes something a function. Well, in order for something to be a function, what it has to do is it has to pass something that we call the vertical line test. Let's get a pen here. We want to pass something called the vertical line test. And what that vertical line test means is that for every one y value, there is only one, or for every x value, there's only one y value. So each of these only goes to one. We would never have x going to two different places at once. So we would never see something like this. That wouldn't make it a function. Now, more than one number can go to the same y value for it to be a function, but each x only goes to one y value. And so what that looks like when we graph it is if we have a function that looks something like this, the way that we check to see something, if something is a function, is we do something called the vertical line test, which means that at any point, if I were to draw a vertical line through my function, I would only ever hit one point on my graph. And that's what makes it a function. Now, what does it mean for a function to be a one-to-one function? Well, in order for it to be a one-to-one function, what that means is that each x value goes to exactly one y value, which is what makes it a function. So one y value. And similarly, there's only one x value per y value. So one x per y. So what does this look like? Well, that means that if 1 goes to 2, then none of these other numbers can go to 2. If 3 goes to 4, none of the other numbers can go to 4. 2 goes to 6, 5 goes to 8, 4 goes to 10. Notice how no numbers from x go to the same y. That's kind of what makes it one-to-one. Now, that's easy to see if we have every element listed, but that's not always the case. So how do we test if something is one-to-one? Well, what we're going to do is we're going to do something called the horizontal line test. And so the horizontal line test, like the vertical line test, is one where we look at our function. So let's take that original function that we had, the one that looked like this. In the vertical line test, we test vertically and see if it crosses. That's what makes it a function. In the horizontal line test, what we do is we actually check horizontally and see, does it only cross in one place? Now notice right here, our function crosses in 1, 2, 3 places at that horizontal line. So this function here is not a one-to-one function. It is a function, but it's not one-to-one. Now, you might be asking yourself, why is that important? Well, it's really important for us to be aware of whether or not a function is one-to-one or whether or not it passes that horizontal line test when it comes to our inverse functions. Now, when we're dealing with inverse functions, because it flips it across that or mirrors it across the line y equals x, what we have to do is we have to have a limited scope that we're dealing with, meaning that every x value goes to exactly one y value. Because if not, and we create an inverse, think of it this way. Do you see how there are 3 points here? Remember, an inverse function switches our x and y values. So then all of a sudden, I would have 1, 2, 3 that are all at the same x value, and no longer do we have a function. And so in order for something to be a function, we want to check to see whether or not it's one-to-one. And if it isn't, we need to adapt the parts of it that we're looking at. So let's take a look at a couple functions here and decide whether or not these functions are one-to-one. So what we want to do first to see whether or not it's a function is check the vertical line test. So here, let's check that vertical line test, and we can see it passes. Next, we want to check the horizontal line test. So I'm going to check that horizontal line test, see if it crosses in more than one place. And this one doesn't. So guess what? Is this one one-to-one? Yes. Yes, it is, because it passes both of those. Now let's try this one, the vertical line test. Yes, it passes that vertical line test. Does it pass the horizontal line test? Yes, in fact, it does. So this one is also a one-to-one function. Let's test this next one down here. So check the vertical line test. Well, this one seems to go through that vertical line test quite well. No problems there. What about our horizontal line test? Right here, I hit it multiple times. Here, I hit it multiple times. Here, I hit it multiple times. It does not pass the horizontal line test. So although it's a function, this one is not a one-to-one function. Now let's check this last one, our vertical line test here. So we can look to see, is this function one-to-one? Well, it passes the vertical line test, but does it pass the horizontal line test? No, 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 no. This one does not. So this one is not one-to-one. So that's how we can do it if we're given a graph. If we are given a table of values, what we can do is similar to what we had here. We can check to see if every x value goes to exactly one y value and each y value is only connected to one x value. The other option that we have is sometimes we're going to be given things like functions, and we need to determine whether or not these functions are one-to-one. Now, the easiest way to do this is actually to graph it in our graphing calculator and see what it looks like. So let's take a look at this function here, x minus 3 squared. Well, when I graph this function, what I end up getting is I end up getting something that looks kind of like this. And then we want to ask ourselves, does this function pass our vertical line test? Yes. Does it pass the horizontal line test? No. So is this one one-to-one? No, it's not. Let's check this next one. Now, these signs here, a reminder, are absolute values. So this means we have an absolute value function, and the absolute value function typically looks like this. So as we graph this absolute value function, what we're going to find out is that this one ends up looking like this. And although this one passes our vertical line test, because it's a function, it does not pass the horizontal line test. So this one is also not a function. Now let's take a look at this last one here, 4 over x. Now this function here is actually called a rational function, is the name that we give that. And it's just 4 divided by a variable. So a rational function is where our variable is in the denominator of a fraction instead of the numerator. And when we look at the graph of these ones, they have a kind of a unique curve to them. What they end up looking like is they end up doing something like this. This is what this one looks like. And we can evaluate, is this one one-to-one? Well, let's take a look here. Does it pass the vertical line test? This looks like it doesn't here, but it does, because those lines go on forever. So it passes the vertical line test. Does it pass the horizontal line test? This one does. Do you see how there's no overlap between those two black lines? So this one is a one-to-one function. So how does this relate to inverse functions as mentioned earlier? Well, let's take a look at some of these functions here and see what happens. So when it comes to looking at these functions and we decide whether or not they're one-to-one, think of what happens when I graph this one. I end up getting x cubed looks something like this. Now it doesn't pass that test. And why does that matter? Well, when we end up graphing the cubed root of x, it looks kind of like this, and it makes a difference as to what our function looks like. Where we really end up seeing a big difference here when it comes to inverse functions is in functions like x squared versus the square root of x. So here's my graph. This is the line y equals x. Inverse functions are reflected directly across that. So if I graph the function x squared, I get something that looks like this. Let's switch colors there. We end up with something that looks kind of like this. Now, if this were to reflect directly across the x-axis and switch, we're going to end up getting something that looks like this. Now, notice how this one is no longer a function anymore. And so because it's no longer a function, this makes it so that we can't have an inverse function. Because think of the square root of x, it's actually only this side. And as we've talked about previously, this is like the fake part of it. It doesn't really exist, but sometimes our calculations think it does. And so what we have to do in situations like this is we have to, when we're finding an inverse of a function that is not one-to-one, limit the domain of what we're talking about. So in this case, what we have to do is we have to say, I'm only going to look at one piece of this x squared function. I'm only going to look here and reflect that one, rather than looking at the whole function, because otherwise it doesn't turn into a function when we reflect it, which is why the square root of x is only positive numbers, meaning that our domains in both cases are only going to be the positive numbers. So that is what makes something a one-to-one function, is it passes that vertical line test or the horizontal line test, meaning for every one x value, there is only one y value. And for every x, there's only one x per y. So there's not two numbers that go to the same place, meaning it passes that horizontal line test. If you have any questions, feel free to reach out, but that is one-to-one functions.